Now let's move on to the measures of association between two variables. So thus far, we have examined numerical methods used to summarize the data for one variable at a time. So X lang to atong mga ipang-compute, diba? X ra itong gikuan ng z-score, itong gikuan ng mean, variance, standard deviation, diba? Those only involve one variable. Now this time we are dealing with two variables. So oftentimes a manager or decision maker is interested in the relationship between two variables. So in this part, I will present to you the covariance and correlation as a descriptive measures of the relationship between two variables. So again, atong combinations or what will be match or what we'll be using is through determining the covariance and correlation coefficient. So first is there we have the application concerning a stereo and sound equipment store. So kana siya mo na siya imong data from week 1 to week 10. So you have the number of commercials, which is your X, and then the sales volume as your Y. So now we are again dealing with two variables na. So the store's manager wants to determine the relationship between the number of weekend television commercials shown and the sales at the store during the following week. So meaning, nabay murag gi-test niya if nabay effect ang commercials sa sales sa imuhang business. So mo ni ang iyahang ganahan i-test. So that is why we are already dealing with two variables. So in this case, again, we have a data set comprising of 10 observations. So one observation per week. So first, let us start with the covariance. Covariance is a measure of the linear association between two variables. So, positive values indicate a positive relationship, while negative values indicate a negative relationship. So, how do you get the covariance? So, mo ni imong formula sa imong covariance, no? So, the formula for your covariance for a sample, so mayroon mo covariance is mo siya yung symbol, the S, and then IXY sa ubos for a population, kaya katong fancy na O, and then XY. So, again, their difference when it comes to the mean and the sa sample is of course sample mean iyang gamit. For your population is of course the population mean, and then for the denominator again the sample is -1, and then for the population is the n. So let's try to get the covariance for this example. So again, your number of commercials is your X, and then your sales volume is your Y. So first thing we need to get is your X minus the mean of your X, and then your Y value minus the mean or the deviation about the mean. So diba mo ni siya. So let's get the mean first. So we have a mean of 3 for the x value and a mean of 51. So that is our mean. So this is your x minus your mean. And then this section is your y minus your mean. Mean of the x, let's just place it here. Minus x mean, and then this one is the y mean. So your x minus your mean. Let's put an absolute reference so that it will be easier. Okay, so there you go. And then for the y, let's add an absolute reference. Okay, so you already have here this part and the second part, the x part and the y part. Now again, we need to get the product of this side and the other side. So let me adjust this for a while so that you can see all the values. Okay. So I will just place here column D multiplied by your column E. Okay, so again, column D multiplied by your column E. So we will get this. And then our numerator is the sum, or this area right here. So this is your sum. Before that, again, multiply this one, your x about the mean and the y. So let's get the sum. Oops. I included there. So you have a sum of 99. Now we already have our numerator. For our denominator, let's just n minus 1. So we can already get the covariance is 99 divided by your n minus 1, which is 11. So you have, well, not 11, but rather 9. So that's 10 minus 1. So sorry, it's 9. So you have a covariance of 11. So this is this is how you get the covariance. And then in this case, since it is a positive, meaning there is a positive relationship between the commercials and the sales volume. So meaning the commercials have effect on the sales volume of the store. So that's how you interpret the covariance. So that's it. Next, we need to move on to the correlation effect. Now, correlation is a measure of linear association and not necessarily causation, meaning wala siya cause and effect, diba? Unlike the covariance, diba, more siya cause and effect because as you can see here, ang number of commercials kay na siya effect sa sales. So the more commercials shown for that week is na siya or ni-increase po siya, or there are signs that there were increase in the sales for that week as well. So that is why more siya cause and effect. Now in correlation, that is not always the case. So just because two variables are highly correlated, it doesn't mean that one variable is the cause of the other. So mo lang siya ang difference. See? the difference sa correlation. So, how do you get the correlation coefficient? So, we have here the R for a sample correlation coefficient R, then XY, then your covariance, diba? This is your covariance ganiha, and then your standard deviation for X times standard deviation for Y, and for the population is a population na pud na side. So your population covariance divided by your population standard deviation for X, and then times multiplied by your population standard deviation for Y. So ana siya yung correlation. So this one, muna siyang pag-analyze nimo for the correlation coefficient, or if you have the results. So a correlation coefficient can take on values between -1 and +1. Values near -1 indicate a strong negative linear relationship, while values near +1 indicate a strong positive linear relationship. The closer the correlation is to 0, the weaker the relationship. So, muna siya sa imuhang correlation. So, this is the example. We already showed the example for the variance side. So, this is what we compute a while ago. So, again, sample covariance. Now, let's try to get the sample correlation, or if we try using Excel, will we still arrive with 0.93? So again, the computation for the sample correlation is you need to get the standard deviation for your X and Y. So STDev for X and then STDev for Y, because we will need that in our computation. So sample, since we are dealing with a sample, for X and then for Y. So here we already have our standard deviations. So you can still also see it here on 0.49 and 7.93. Now for the correlation, let's just name it COCO. Correlation coefficient. Let's just say COCO. Correlation coefficient is again your covariance divided by the product of your standard deviations for X and Y. Let's place it in a parenthesis. And your Y. So here you have a correlation coefficient of 0.93, which still same amount was shown here. So that is how you get your correlation coefficient. Now it is near 1. So if we go back to the analysis right here, if it is near 1, there's a strong positive linear relationship between the values. So meaning, if the value for X increases, since strong positive linear man, so it has an effect on the value of your Y. So that's how you get it. Now, what we were using was we were following the manual. So kato na formula, kanisya na formula is manual computation. If we make use of Excel functions, so we just simply make use of the functions covariance and correl. So again, let's try here. MS Excel way. Covariance. And then correlation. Okay, so if you do it the Excel way, just simply covariance. So again, you have two options, .p and .s. So P for population, S for sample. And then array 1 is your X, array 2 is your Y. but it doesn't really matter if even if it will interchange. So still, as long as you have or you've given the two data values, it would still result. It would still arrive at the same result. So again, you have 11, and then for the correlation, you simply make use of the function correl, and then again select your two data values for your x and y. And as simple as that, that's how you get the covariance and correlation using the Excel way. So you don't need to get these columns. If mag-Excel ka, di na kailangan mag-compute pa sa division about the mean. So, as long as naka sa imong x values ug y value, you just make use of the covariance and then the correl for the correlation nga function. So, makuha na dayon nimo ang imong covariance og correlation. So, that's how you measure the relationship given two variables. So that's how you measure the association between two variables.